Let's read the question, students. Which of the following is a pseudo first order reaction? Students, among the given options, this is very clear that the option number 4 is a pseudo first order reaction, as the hydrolysis of ester in acidic medium is an example of pseudo first order reaction. That means the correct answer for this question is option 4. Moving to next question, students, which is question number 77. Let's read the question, students. The half-life of a first-order reaction is 10 minutes. The time required for the concentration of the reactant to fall from 2 milligram per liter to 0.25 milligram per liter is. Student, in this question, first of all, students, this is a very important question. In this question, we are given with half-life period for a first-order reaction, and we have to calculate the time required for the given change in the reactant. In this case, the reactant initially given is 2 milligram and the final reactant left is 0.25 milligram. If you want to do this question verbally, we can see that in first, so students, let's proceed this question. So let's calculate the time required for the given change. We'll be using a formula. Amount of reactant left after time t is equals to the initial concentration of reactant multiplied by half raised to the power t upon t half. Here t half is half-life period. So amount of reactant left after time t is 0.25. It's already given. So 0.25. The amount of reactant initially given is 2 milligram per liter. So 2 multiplied by half. T we have to calculate, and the value of t half is already given, which is 10 minutes. So t upon 10. Now student, let's further solve this question, students. This would become 1 upon 2 raised to the power 3, 1 upon 2 t by 10. So t by 10 is equals to 3, or we can say that the time required is equals to 3 multiplied by 10, that is 30 minutes. So the correct answer for this question is option number 4. Moving to next question, students, which is question number 78. Let's read the question. For the reaction 2A gaseous plus B gaseous give half C gaseous, the value of rate of disappearance of A is given as 2 multiplied by 10 raised to the power minus 2 mole per liter per second. The rate of formation of C and the rate of reaction are given respectively as. Students, for this question, first of all, I'm writing the expression for rate of reaction. So, rate of reaction is equals to 1 upon 2 minus change in concentration of A upon time taken is equals to change in concentration of B upon dt, that is time taken, which is equals to 2 into change in concentration of C upon time taken. We have to calculate the rate of formation of C. So, rate of formation of C is equals to change in concentration of C upon dt, and we are given with rate of disappearance of A. So let's take these two terms. This will be equals to 1 upon 4 dA by dt minus, since we are given with rate of disappearance, which is equals to 2 into 10 raised to the power minus 2. So 1 upon 4 multiplied by 2 into 10 raised to the power minus 2, which is equals to 5 into 10 raised to the power minus 3 mole per liter per second. Now student, we have to calculate rate of reaction. Since rate of reaction is equals to 2 multiplied by the rate of appearance of C. So rate of reaction is equals to 2 multiplied by the change in concentration of the product C, that will be equals to 2 multiplied by 5 into 10 raised to the power minus 3, which is equals to 1 into 10 raised to the power minus 2 mole per liter per second. That means the correct answer for this question is option number 3. The rate of formation of C is 5 into 10 to the power minus 3 and the rate of reaction is 10 raised to the power minus 2 mole per liter per second, that is molar per second. So the correct answer for this question is option 3. Moving to next question, students, which is question number 79. Let's read the question, students. In a reaction, A plus B gives product. The rate of reaction remains same when the concentration of A is tripled, and rate increases by a factor 4 when the concentration of both the reactant A and B are doubled. The rate law of the reaction can be written as. Students, for this question, first of all, we need to see that the rate expression is given as rate equals to K, that is rate constant, then the concentration of A raised to the power X and the concentration of B raised to the power Y. In this question, we are given that the rate remains same when the concentration of A is tripled. That means, let's take it as rate is equals to K 3A X B Y. The rate remains same when the concentration of A is tripled. Now let's read the next statement. The rate increases by a factor of 4 when the concentration of both reactant A and B are doubled. That means the rate becomes 4 times when the concentration of both the reactant, that is A and B, becomes double. When we'll solve these two equations, the value of X will be 0 and the value of Y will be 2. That means we can write the rate law. Rate is equals to K concentration of A raised to the power 0 and the concentration of B raised to the power 2. That means the correct answer is option number 2. Moving to next question, students, which is question number 80. Let's read the question. Select the correct options among the following. Students, in this question, we are given with certain formulas and we have to identify that which is a correct one. So let's see, number 1, it's given as enthalpy of reaction. Student, enthalpy of reaction is equals to activation energy for forward reaction minus activation energy for backward reaction. This is the correct option. Moving to next, the threshold energy is equals to energy of reactant plus energy for forward reaction. Threshold energy is equals to energy of reactant plus energy of forward reaction. Student, this is also a correct option. Let's find out the last statement using Arrhenius equation, which is equals to K is equals to A, that is Arrhenius constant, E raised to the power EA, that is activation energy, upon RT. So let's take the natural log. Ln K is equals to ln A minus EA upon RT. That means option number 3 is also correct. So all the given 3 formulas are correct. That means the correct answer is option number 4. Moving to next question, students, which is question number 81.